Okay, folks, we have been the last couple weeks looking at two equations at once, which we call a system of equations, and we've been trying to find the points that they have in common, right? We started out where we would have two equations and we would graph them and we would look where they cross. That's how we did it the first week. Then we started to realize that that doesn't always lead to the most precise answers, so we started to look at how to do it algebraically. That's what we did the week after that. So the last 2 weeks we have been looking at this. Now, what I want to do this week is just review. So nothing new, but just review those two methods to make sure that we really understand how to find, when you have two equations, how to find the point they have in common. So let's go back and let's just start over with the graphing. So if I want to know the point that these two equations have in common, I'm going to graph using my slope and my y-intercept. They're both in slope-intercept form. So for the first one, the starting point, the y-intercept is -4. So I'm going to go down 4, 1, 2, 3, 4, and I'm going to put my y-intercept right there. Now my slope is the number in front of the x. Since there is no number in front of the x, we know that means there always is a 1. So my slope is 1. Remember, when the slope is a whole number, you can think of it as over 1 to make it into a fraction. So from this point at -4, I'm going to go up 1 and over 1 and put a dot. And then up 1 and over 1 and put a dot. Up 1 and over 1. And I just did it a few times. Right? Because remember, precision here, we're going to end up trying to figure out the point that the two lines cross. So if you have a ruler axis, it can be really helpful. Okay, so I started at -4 because that was my y-intercept, and then my slope was 1, so I went up 1 over 1, up 1 over 1, and drew the line. Okay, now for the second line, my y-intercept is 1. So I'm going to start up 1 and put my dot there. And now my slope is -2/3. So remember, rise over run, I'm going to go down 2 and right 3. So down 2, 1, 2, and right 3. 1, 2, 3. Boom, there's the point. So I draw this line, right? And there's the point where they cross. That's the point that I'm interested in. So the last thing I have to do is just label that point with the coordinates. So that point there looks like it's 3 to the right and 1 down. So 3 to the right means it's the x is 3, and 1 down means the y is -1. So the point that they have in common is 3, -1. Okay? So this is how we were finding the point that the system had in common for the first week. We were graphing them. All right, so let's do one more graphing one like that. Maybe you can pause the video, try it yourself, and then I'll come back and go over it. So y equals -x plus 4, and then y equals 4x minus 1. Okay? So why don't you try that? I'm going to draw out my axes, and if you need more time than that, then just pause the video, and then we'll come back and we'll go over it. Okay? Okay, so again, pause the video if you need more time, and then come back and we'll go over it. All right, so now I'm going to graph these two lines and look for where they cross. So I start with the first one. Again, my y-intercept is +4. So 1, 2, 3, 4, up 4, I'm going to put a dot. And now my slope, once again, there's no number in front, so I know my slope is a 1, but since there's a minus, it's actually a -1, right? And I put it over 1. So my slope is -1. So from this point, I'm going to go down 1 and right 1. Down 1 and right 1. Down 1 and right 1. Okay? So down 1 over 1. Down 1 over 1. Down 1 over 1. And there's my line right there. Okay? Now the next one, my y-intercept is -1. So I'm going to start down 1, and I put a dot. And now my slope is +4. Again, I think of it as over 1, so positive 4 over 1. So from here, I'm going to go up 4 and over 1. Up 4 and over 1. Boom. There we are. Draw the line. So again, I'm looking for the point that they have in common, and there it is. There's the point where they cross. And now all I have to do is label the coordinates. So that point looks like it's over 1 and up 3. So that means the x coordinate is 1 and the y coordinate is 3. So that is the point that they have in common. Okay? So this is what we were doing to find the point they had in common for the first week. We were doing this type of practice. But then we got to the point where we realized this isn't always precise. I mean, if I was a little off in my drawing of my graphs, then I might not be able to get that precise answer. So we looked for an algebraic way to do this. And so we started to do it with substitution. So let's just review that. That's what we did the next week. And I made a video on that, and then I posted some other videos from online. So you can refer to those as well. So let's say we had this equation and this equation. Now this is a particularly good example, I think, because if we tried to graph this one, the numbers are bigger. So it would be harder to fit it on my grid. I'd have to change my scale, and the numbers are bigger. So this is a perfect example of one that, since the numbers are a little bigger, let's solve it algebraically, okay? And the method we talked about was substitution. So the way we said you could do this, since they're both equal to y, is you could take one of the equations and put it right next to the other equation. So I would have negative 5x minus 7 equals 6x plus 15. Perfect. Right? And now I go ahead and I solve that, which we have been working on solving that for a while. You got to move all the x's together, and then you go from there. So here, I'm going to take the 6x, and I'm going to move it over with the 5x. Since I'm moving across the equal sign, I have to do the opposite, the inverse. So I'm going to minus 6x. So minus 5x minus 6x, that's going to make negative 11x. Minus 7, this is now gone, and I get 15 over here. Right? And now I finish up. Inverse operations. Instead of minus 7, I plus 7. So 15 plus 7 is 22. And then divide by negative 11 because it's multiplication, so the opposite is to divide. And it looks like x comes out to be negative 2. So that is my x value, negative 2. But again, remember, we are not done these problems until we have a set of coordinates. So you can't just say, oh, the answer is x equals negative 2. Remember the two problems we just did, we had to give an x and a y so we could locate the point in the coordinate plane. So I still have to take this negative 2 and put it up here into one of these equations, either equation, and figure out what y is. I'm going to use the bottom equation because it has less negatives. So y equals 6x plus 15. So in the place of x, I put negative 2. Y equals 6 times negative 2 plus 15. So 6 times negative 2 is negative 12 plus 15. So that looks like the y comes out to be 3. So x is negative 2, y is 3. Now you have your final answer. If you want to write it that way, that's great. Or if you want to write it like a set of coordinates like we did with the graphing ones, that's great too. So this is how we were able to solve these algebraically without having to graph, by taking the two equations, putting them next to each other, and just doing out our solving. Okay? Let's do one more like that. And then again, all we're going to be doing this week is practicing. Okay? So if I give you y equals 4x minus 11, and y equals 2x minus 3. Okay? Why don't you go ahead and pause the video and try that on your own, and then we'll go over the answer. Okay, so once again, I want to try to find the point that they have in common without graphing it. So I'm going to do it algebraically. So I'm going to take the top equation, and since they're both equal to y, I'm going to put it next to the bottom equation. So it'll be 4x minus 11 equals 2x minus 3. Okay, and now I'm going to finish up the solving. I'm going to bring the x's together. I'm going to bring this 2x over with the 4x. So since I'm moving across the equal sign, I have to do the inverse. So I'm going to minus 2x from both sides. Anytime you move across the equal sign, you have to do inverse operations. So 4x minus 2x is 2x minus 11. And then over here, I just have the minus 3. Now, I go ahead and I'm going to finish up. Minus 11, I'm going to plus 11. So that's 2x, and then minus 3 plus 11 is 8. And then lastly, I divide by 2. And so x comes out to be 4. Okay? But again, I'm not done because I only have an x coordinate. I need an x coordinate and a y coordinate. So I got to take that x equals 4, and I got to plug it into one of these equations, either one. Okay? Let's plug it into the top one this time, just to show it doesn't matter. So 4x minus 11. So if I put the 4 in for the x, then that'll be 4 times 4 minus 11. And 4 times 4 is 16, minus 11, and it looks like the y comes out to be 5. So our solution is x equals 4 and y equals 5. That's the point in the coordinate plane where the lines will cross. Again, you can write it like that, or if you want to write it as an ordered pair, make sure you put the x first and the y second. Okay? So that's a quick review of what we have been doing for the past couple weeks. Graphing the lines and looking for where they cross, but also doing it algebraically, finding the point where they cross algebraically by substituting and putting the two equations next to each other, finding x, and then substituting back in to get y. Okay? All we're going to be doing this week is this review. So practice. If you have questions, email me. Use this video. You can look at the back of the videos that I posted for the past couple weeks as well. All right? Have a great day.